All right, students, let's do a radical lesson here. We're going to start by learning how to simplify radical expressions, including adding, subtracting, multiplying, dividing, and rationalizing them. This first lesson will just be simplifying radical expressions. So instead of approximating what the value of each expression is using a calculator, we are going to simplify them, kind of like simplifying fractions. So the first thing you're going to want to do is think about what factors the square root of 75 has. And the factors of 75 are 1, 3, 5, 15, 25, and 75. And a radical expression can be simplified if there are any perfect square factors. Now, when you're doing this, you're going to go through this list and look for perfect squares, and you always want to pick the perfect square factor that it has that is the greatest. So we're going to use 25. So we're going to rewrite this as the square root of 25 times the square root of 3, which is the same as the square root of 75. And now the square root of 25, we can just write that as a whole number 5. So in simplest radical form, we call it, simplest radical form of the square root of 75 is 5 times the square root of 3. Now the square root of 16 is equal to 4 because that's a perfect square. So we're going to move on down to another example where we have to simplify it a little bit. Let's do the square root of 80. So we want to think about what perfect square factors 80 has. The factors of 80 are 1, 2, 4, 5, 8, 10, 16, 20, 40, and 80. So the greatest perfect square factor of 80 is 16. So we're going to use that in writing our simplified expression. So we're going to write the square root of 16 times the square root of 5. And then we're just going to rewrite the perfect square part of that as a whole number. So equals 4 times the square root of 5. And we're done. All right, let's do one more and then we'll move on to another page. Let's go down and do the square root of 108, number 12 here. So the perfect square factors of 108, and I don't want to list these, but they're 1, 2, 3, 4. 4 is a perfect square. 6, 9, 12, 18, 27, 36, 54, and 108. The greatest perfect square factor is 36. So we're going to use that in simplifying this. So the square root of 108 is the square root of 36 times the square root of 3, since 36 times 3 is 108. And the square root of 36 is 6. So in simplest radical form, the square root of 108 is equal to 6 times the square root of 3. Let's move on to the next page. Of course, you can stop this video if you want to practice some of those problems before you start the next set. There's a couple examples here. When adding or subtracting radicals, they need to have the same radical in each. So they need to have like radicals in order to combine them. And you can look at the examples and see that, but we'll start right here on number 1. And you notice that both of these have the square root of 6 multiplied by them. So that means we can use the distributive property, and we could write this as the square root of 6 times 3 minus 4. And 3 minus 4 is just negative 1. So it's negative 1 times the square root of 6, which we can just write as the negative square root of 6. So in the second problem, again, we have a common factor of the square root of 7, so we can use the distributive property here and write it this way. And negative 3 plus 4 is just 1. So we have 1 times the square root of 7, which is just the square root of 7. Again, in this one, we have a common factor of the square root of 21. So I can use the distributive property and write it this way. And negative 11 minus 11 is negative 22 times the square root of 21. So we're just going to write this as negative 22 times the square root of 21 like that. Now, basically, we're just combining like terms. So if you notice that they have like radical expressions in them, really you could just add the numbers out front. So negative 9 plus 10 is 1 times the square root of 15. And of course, when we multiply by 1, we don't even write that number there. So go ahead and try a few of these and move on to the next lesson, next page when you're ready. All right, in this part, we're going to learn how to simplify radical expressions by multiplying. Now just think about as you do this, how you multiply expressions together. So if they're both whole numbers, you just multiply. If you're multiplying a number times a radical, you can't really combine those in any way, so you just write 2 times the square root of 5. Which is also equal to, well, square root of 2 times 5, we would just write it, put the whole number out front and write it as 5 times the square root of 2. In this example, we have the 2 and the 5 that we can multiply together because multiplication is associative and commutative, so we can rearrange it any way we want. But we're going to multiply the 2 times the 5, so we get 10 times the square root of 3. You can multiply square roots together, so this would equal 2 times the square root of 15. And in this last example, there's 2 whole numbers we can multiply together to give us 8, and then there's 2 square roots we can multiply together to give us the square root of 15. So thinking about those, in this first example, we can multiply these 2 square roots together. That'll give us 4 times the square root of 36, and the square root of 36 is equal to 6, so we have 4 times 6, which is 24. In the second example, we can multiply, we have a negative times a positive, so we're going to get a negative answer. We can multiply the 2 square roots together. 5 times 20 is 100, and the square root of 100 is actually 10, so we get negative 10 for an answer. Let's slide down here to number 8. I'm going to do one more example here. On number 8, we have 2 square roots that we can multiply together. So the whole number 3 times the square root of 15 times 5 is 75. Now, 75 has a perfect square factor, so we're going to want to simplify that. The perfect square factor is 25, so we're going to write 3 times square root of 25 times square root of 3, because 25 times 3 is the same as 75. And that's 3 times 5 times the square root of 3. So in simplest radical form, it's 15 times the square root of 3. All right, you can try some of those and move on to the next page when you're ready. All right, on this last page, we're going to learn how to simplify radical expressions by rationalize the denominator. Before we do that, let's go over a few rules. We're going to say that it's going to be fractions are going to be considered simplified if they follow these rules. There's no perfect square factor under the square root. There's no fractions under a square root. There's no square root in a denominator, and the fractions must be reduced. Just thinking about dividing, 6 divided by 3, of course we can just divide those because they're both whole numbers. We can also divide square roots if they're both square roots. So this equals to the square root of 6 divided by 2, and 6 divided by 2 is equal to 3. So square root of 6 divided by the square root of 2 is equal to the square root of 3. Since in this next problem we have a square root on top and a whole number on the bottom, we really can't divide those and make it any simpler. On this next problem, you can see that there's a fraction in here that's not reduced. 12 divided by 2 is equal to 6. So we can write this as 6 times the square root of 6. And then this last problem, we have two radicals that we can go ahead and divide. 6 divided by 2 is 3. So the square root of 6 divided by the square root of 2 is equal to the square root of 3. We can simplify that. All right? Now, if you have a square root like this in the denominator, we want to get rid of that. One of the rules, rule number 3, is that you can't have any square roots in a denominator. And the way we're going to do that, this is called rationalizing the denominator. If I were to multiply the square root of 7 times the square root of 7, that would equal the whole number 7. Now you can't just multiply by any number you want, but if you multiply by the square root of 7 over the square root of 7, you're really just multiplying by 1. And we know that multiplying by 1 doesn't change the value of the number at all. It just kind of changes the way it looks. Now we have the square root of 56 on top, because the square root of 8 times the square root of 7 is the square root of 56. And the square root of 6 actually has a perfect square factor of 4. 4 times 14 is 56. So I'm going to write it that way. And the square root of 4 is 2. So I end up with 2 times the square root of 14 over 7. Okay. Number 12, again, has a square root in the denominator. We can't have that. So we're going to multiply by the square root of 7 over the square root of 7 to rationalize that. So on top we have 7 times the square root of 7. On the bottom we have 8 times 7, because the square root of 7 times the square root of 7 is 7. And notice we have a 7 over 7 here, which is just 1. So we can simplify that. And that equals the square root of 7 over 8. Number 13, we're going to multiply by the square root of 6 over the square root of 6. That's going to give me the square root of 12 in the numerator and 6 in the denominator. Now 12 has a perfect square factor of 4, so we want to factor that out and write that as 2 times the square root of 3 over 6. And you're going to notice that we have a fraction now that's not reduced. And so we're going to reduce that fraction of 2/6, and that's the same as 1/3. So we have 1 times the square root of 3 on top and 3 on the bottom. And now it's simplified. In this last example, we actually have a fraction under the square root that we could simplify first. And that's because there's a common factor of the square root of 3 in both the numerator and the denominator. So I'm going to write it like this. And those square roots of 3, they'll cancel out because they equal 1. And so now I have the square root of 7 over the square root of 5. I need to rationalize that square root of 5, so I'm going to multiply by square root of 5 over square root of 5. And that gives me the square root of 35 over 5 for my answer. All right, so go ahead, try some of those. There's some more practice problems you can do on the following pages. If you have any questions, come in and see me, and we'll do a few more examples with you. Thanks for watching this video.